Hello everyone, and welcome. Have you ever wondered what happens when water turns into ice? Or how a chocolatier gets that perfect snap in a chocolate bar? The answer to both is a fascinating process called solidification. Today, we're going to break down what solidification is, how it works, and why it's so important in our daily lives, from the kitchen to advanced manufacturing. At its core, solidification is simply the process of a liquid changing into a solid. It's a type of phase transition. This happens when the liquid cools down. As heat is removed, the tiny particles, like atoms or molecules, inside the liquid lose energy. They slow down and start to arrange themselves into a fixed, ordered pattern, creating a solid structure. The most common example is water freezing into ice. When you place liquid water in a freezer, the freezer pulls heat away from it. The water molecules stop moving around so freely and lock into a rigid crystal lattice, forming solid ice. But how does this process actually start? It happens in two main stages. First is nucleation. Think of this as the very beginning, where the first tiny solid crystals, called nuclei, form within the liquid. It's like the first seed of a crystal being planted. This can happen randomly in a very pure liquid, which is called homogeneous nucleation, or it can happen on a surface, like a speck of dust or the side of the container. This second type, called heterogeneous nucleation, is much more common because it takes less energy. The second stage is growth. Once these tiny nuclei have formed, other particles from the surrounding liquid start to attach to them. The solid crystals grow larger and larger, expanding until all the liquid has turned into a solid. These growing crystals are often called grains, and their final size and shape are incredibly important. So why should we care about this? Because controlling solidification allows us to create the world around us. In metallurgy, engineers carefully control the cooling rate of molten metal to create strong and reliable parts for cars, planes, and buildings. Faster cooling often results in smaller grains, which can make a metal stronger. In the kitchen, tempering chocolate is a perfect example of controlled solidification. The process creates a specific crystal structure that gives chocolate its desirable shine, snap, and smooth texture. Even nature uses solidification. Geologists study how molten magma cools and solidifies to form rocks like granite. The slow cooling deep underground allows very large, beautiful crystals to grow. So, to sum it up, solidification is the transformation from liquid to solid, driven by cooling and occurring through nucleation and growth. It's a fundamental process that shapes everything from our ice cubes to the very ground beneath our feet. Thank you so much for watching. If you found this explanation helpful and learned something new, please give this video a like and consider subscribing to the channel for more simple science breakdowns. It really helps us out. See you in the next one.